Hello, it's time now. So good morning, good afternoon, and good evening to everyone all around the world. We have students for AMC 8 from America, then in China, and then also we have students in Australia and New Zealand. So I will say good morning, good evening, and good evening. Oh, sorry, good afternoon and good evening. So from now, we will have a long journey from April to October, half a year. Now, the topic of lecture 1 will be operations. It will be some basic knowledges about AMC 8. Well, before we start our session, let's see our schedule and target. As I mentioned, we will have a long journey around 7 months, and the course will be divided into 25 topics covering all the fields of AMC 8, then plus 5 mock tests. Typically around, for each 5 topics, we will have a mock test. We will be doing the mock test online, and you will get your scores, and we will give some live explanation to the mock test. Then the topics will be covering algebra, number theory, geometry, and combinations. So this will be the 4 main fields about AMC series. Then our purpose is to build a very strong problem-solving capacity. You will not learn how to get a high score in math contest, but also some way to think and to improve yourself and to get interested in mathematics. Okay, then we will start our problem 1 today. So you may think that this will be problem 1 in real AMC 8 test, right? It's too simple. But when you are doing the problem and calculating, be careful. Otherwise, you may not get a 100% correct answer, right? You can type your answer in the chat room so I can see. Also, you can show the way you think. Okay. Yeah, this is not a very hard problem. So I think some of you may have already get your answer, right? So would you please type it in the chat room? Yeah, now, as I said, the problem is not that easy, right? I made some adjustment in the problem. So be careful as a hint. There may or may not be some traps. Up to now, I have seen only 1 correct answer. And those who using Xiaoe system, you can also type your answer into the chat room so I can see and reply. Now, you may think that this is a simple problem. Yes, it is. But up to now, I can see only 1 correct answer from Mandy Yu. And Hank Sun noticed there is a trap. But unfortunately, he still gets a wrong answer. Let me see if I missed any correct answers. Up to now, only Mandy Yu. Yeah, another from Yang Zaiyi, right? Yeah, David Chen is brave and he typed his answer into the public, right? Yeah, gradually, most of you, after the first hint, you successfully find where the trap is. Now I can see a bunch of correct answers. Let me see that. Sally Yu. Yeah, I think I have already called the name. Ellie Zhou, Charlie Yang, Hank Sun, Avery Ma. Evanston, and then Jonathan Wang, Edward Huang, Amber Wu. Then, okay, so let's solve the problem together. Before solving the problem, I want to show you some rules and methodologies to speed up your calculation. Yeah, that is called. The order in additions does not matter. So, for example, this is the original problem. You can change the order of any numbers to any place if you want. So we are going to find numbers that has a sum of multiples of 10, 100, 1000, and something like that. So if we write the numbers again, the first thing you will see that there will be something relevant to 742, right? If you read the problem carefully, well, in AMC 8 level calculation, it won't be very large numbers, right? So if you see such pairs, you know that they have a sum of 1000. Yeah, it is very simple. Then you can see other pairs, right? When you see the last digit of 2, you will find 8. When you see 5, of course, you will find another 5, right? The second pair. Then gradually, you know, with these steps, we will divide the numbers into 4 different groups, right? It's like that. When you are playing the game, you will find a partner. Of course, you will find the one who you like best, right? Yeah, they are pairs by pairs. But here, you know, when you find the first pair has 1000, yeah, then 1000. You may think that it is 4000, right? 4 pairs. Yeah, the second pair is 1000. Then question here, what is the sum of the third pair? For those who successfully found out where the trap is, we get the correct sum of the third pair. I think most of you do not even calculate the sum of the third pair. Then you think they are all 1000, right? Yeah, smart. I know for those who get the correct answer, you know it's not 1000, but 1010. You know, either 87 plus 913, not 23, has a sum of 1000, right? There will be 10 larger than 1000. So here is the trap, right? Be careful about here. There is. So for the last pair, well, it will still be 1000. So overall, the sum is not 4000, but 4010, right? You know, for the first problem, you just need to take good advantage of the orders do not matter in addition, right? But be careful, you still need to do the sum, right? Yeah, we can make pairs that are perfect numbers like 1000, but sometimes they are close. Be careful, right? This is the sum of 1010 is made on purpose, right? To test whether you have paid enough attention to the numbers. Okay. And finally, we have the correct answer, right? And there is something similar with orders in addition, that is multiplication, right? While still in multiplication, orders do not matter again. Then we can find the product of something like multiples of 10, 100, 1000. So there are some commonly used pairs, right? For additions, when you see the last digit be 8, you will always find 2, right? To make a multiples of 10. Here, we will see that the product of 5 and 2 will be 10. And then 25 by 4, 125 by 8, right? So these 3 pairs will be commonly used. Well, for example, if we are calculating 75 by 16. Typically, we need a column calculation, right? Well, here actually, you know, it is related to one pair. That is 25 by 4, right? You may ask, where is 25 now? Yeah, we don't have 25 here, but we can make one ourselves, right? 2075 can be expressed as 25 by 3, right? Then we have 125 now. Then you may keep on asking, where is 4 now? So 16 can be expressed as 4 by 4. Then here, as order does not matter in multiplication, now we can make another group, right? 25 by 4. Then you know the rest too has the product of 12. 3 by 4, we have 12. Then multiplied by 100. So overall, 75 by 16, we know that is 1,200, right? Or 12 followed by 2 zeros. Is it much faster? You know, I have to explain to you, so I write too many things. Otherwise, you can get it directly, right? 12 by 100. Okay, remember, orders do not matter in both additions and multiplications, right? It will speed up. And you know, in a typical AMC 8 test, you have 40 minutes for 25 problems. If I am correct, 96 seconds for one problem, right? A little bit more than 1.5 minutes, right? Okay, let's move on to problem 2. Oh, you will think it's still a simple calculation, but we do have so many zeros after the decimal points. Yeah, this is a problem about decimals. You will pay much attention. So remember what many of you get 4,000 in the first problem, right? Though after a short while, you have changed that to the correct one, but always be careful, right? Then for the second problem, what is the number of n? It is an n-digit number for the result, right? Any answers? You can type that into the chat room. Okay. Oh, I'm waiting for, yeah, I saw the first answer, so it is too large. It will be too large, right? Well, we can make a rough estimation for this problem. How large could it be, right? When we are talking about n-digit number, probably it's likely to be an integer, right? Otherwise, you know, we do not always define decimals as n-digit, right? So the first hint is that the number is probably an integer. Oh, of course, it's positive, right? Well, we do not need the 9. I have seen the first close answer. Well, as a hint, let's look at the rule. And remember, we are calculating A, then we calculate B, the product of B and C first. Then we calculate what's the value of A divided by the product, right? Well, at the first hit, consider A divided by B. Is it equal to 10A divided by 10B? It means we multiply both the dividend and the divisor by 10. Will the answer still be the same? Well, sometimes the remainder will be different, right? But if we are talking about division itself, the result will always be the same, right? Okay. So, you know, if you write that as a fraction way, you will see the results are the same, right? As the common divisor can be cancelled. Yeah, it's the same, right? So as they are the same, you know what I'm going to talk about, right? So let's see some calculation rule first. You see, if we are calculating something with both multiplication and division, right? So we can change the order. And remember, when we move the numbers out of the parentheses, be careful. The division will be a multiplication, right? And then anything, one divide anything will be the reciprocal, right? We will do the flip. For example, if we are calculate B divided by, here should be A divided by B, right? If we use 1 to divide the, if 1 is divided by the result, you know it is called a reciprocal, right? What we need is to flip the numerator and the denominator, right? Okay, so let's look back to these three numbers, right? You know, when we are calculating this number, can we just throw most of the zeros away? Of course, the decimal. It's disgusting, right? We don't need that. So when we move, let's look at here. When we move the decimals to the right side for one place, it will be equivalent to multiply by 10, right? You see, if we move the decimal to the right side once, it will be equivalent to multiplying by 10, right? Then if we move the decimal to the right place twice, it will be, according to the pattern, it will be equivalent to multiplying by 100, right? So here, if we want to make it an integer, how many times shall we move the decimal? You see 1, 2, 3, 4, 5, 6, 7, right? So if we make A, you see we have 7 zeros, right? We just write a circled number for 7 zeros. It will be 12, right? Then we will do the same operation on B and C. But be careful, for B and C, we still need to count again, right? How many zeros? It will be 8 zeros, right? Or as the number is not that large, you can just write all the zeros down, right? I just give you a circled number to show which number have we multiplied, right? Well, it is 25. And here, another thing is that we are calculating B by C, right? And remember, we do have something that we are familiar with now, right? Then what is C? You see, well, this time C has the same number of zeros after the decimal point, right? With B, still 8. So it is 8. Now we are going to do the multiplication and the division, right? We will times B and C first. So give me a number. How many zeros does B and C have when we multiply them together? You see on the right side, that is 200, right? You see this can be expressed as 4 by 2. So remember 25 by 4, it will be 100, right? So here it is 200. But you see on the left side, if we multiply them together, how many zeros do we have? Question is, how many zeros do we have? This is another question. How many zeros do we have? You see, it's B by 10. You see 8 zeros, right? 1 followed by 8 zeros. It means we move the decimal to the right side for 8 times. Then for B, we still move the decimal to the right side by 8 times. So together, how many times did we move the decimal to the right side? How many times? A number is equivalent, right? So it means we have moved the decimal 16 times to the right side, right? Now, with this equation, what will you do? Here, you see on the left side, we have 16 zeros, and on the right side, how many zeros do we have? How many zeros do we have? Yeah, 2. So what will we do now? There is something called, what can we do? We can do the same operation on both sides. What will we do? What will we do? Yeah, we will cancel some of the zeros on both sides. You know, when the right side becomes 2, it means we remove all the zeros on the right side. So what will be the circle number on the left side? Yeah, we remove 2 zeros on the right side. Yeah, very smart. I saw 14. It's correct. Now on the left side, we have 14 zeros, right? You know, if we move 1 followed by 14 zeros to the right side, then you know it could be written as B by C equal to 2 over how many zeros? You know, we have 14 zeros, right? Then A divided by the number. Remember, what was that B? It will be equal to A times the reciprocal of the number, right? Remember, let's look again at the reciprocal. You see 1 over something will be flipping the numerator and the denominator, right? When I say, you see, flip the numerator and the denominator, right? Flip. When we see, you see A is still, remember, this A by the number will be 12. A itself is this, right? So A can be expressed as 12 over, you know, here we have 7 zeros, right? Then talking about the reciprocal, we just need to flip the numerator and the denominator, right? Flip means when it is the numerator here, it will be denominator in the calculation. Then the denominator will be the numerator, right? We have 14 zeros here. Well, you have learned how to cancel the common divisors, right? You see 12 divided by 2 is 6. Now question here. On the numerator, we have 14 zeros. On the denominator, we have 7 zeros. So overall, after calculation, how many zeros left? Yeah, you know, we can cancel some zeros, right? As the numerator has more zeros than the denominator. You see, when you forget, oh, how can I cancel the common factor? Remember, for the numerators, it means the decimal point has been moved to the right. When it is in the denominator, it means the decimal point is moving to the left part, right? You see, moving to the right for 14 times, then move back to the left for 7 times. Overall, it will be equivalent to move to the right for 7 times, right? Moving to the right for 7 times means we have 7 zeros here, right? Now question here. 6 by the number 1 followed by 7 zeros. How many digits are there? How many digits are there? You see, you can do it like this. Let me use another color, right? 6, it means 6 by 1 0 here. We have 2 digits, right? Then 600, it means 6 followed by 2 0. We have 3 digits. Be careful. Then 6 followed by how many zeros? 7, right? So how many digits do we have? Question here, how many digits do we have? Yeah, be careful. We have 7 zeros, but we have 1 more digit, right? Don't forget the first non-zero digit, right? So here we have 7 consecutive zeros at the end, but we have overall 8 digits, right? Be careful, pay extra attention. There are 2 key points. The first is that we have to find how many zeros will be there in the final result, right? Then don't throw the first non-zero number, right? Be careful. Well, as the number is not that large, you can write it down on the paper, right? It will guarantee you to get the correct one. But when the number is very, very large, for example, it has 1,000 zeros, but you cannot write that down in the paper, on paper, right? So you will pay attention to the pattern. When you see we have 1 0, then 2 digits, 2 zeros, 3 digits, right? There will be always 1 more digit. Okay, that is problem 2. You see, we do have simple calculations, but you know, for the first stage, only few of you successfully get the correct answer, right? Let's look at problem 3. Well, be careful. We do have some. Now this time the points appears above the number, right? It will be called cyclic or repeating decimals, right? Be careful, it's not 0.01, but 0.01 repeated, right? So let me see if any of you have the thoughts of this problem, right? You know, it's not easy to calculate cyclic problems, right? For example, we have to convert the cyclic numbers into a fraction way, right? So for decimals, always remember to use plus and minus. For multiplication and division, always use fractions. You can see samples here, right? Well, before solving the problem together, I will leave you some time to think it. Now let's see some calculation methodologies. For example, if you do, you will need to maybe for something like that, right? Plus 5 over 40. It is 21 over 40. Well, the calculation is correct, but we have a much faster way, right? You see 2 over 5 will be 0.4 and 1 over 8. Remember, 125 by 8 is 1,000. So 1/8 will be 0.125. So isn't it much simpler? So that's why when doing addition and subtraction, we are always using decimals. Then you see here, and vice versa, when we are doing multiplication and division. So you see, if we do a column calculation, it will be much slower, right? But if we use, it's wrong. It should be 9 over 20 by 1 over 4, right? Well, is it much simpler? It is 9 over 80. Right, if you still need the decimal format, it will be faster to do 9 over 80, right? So, okay, let's look back to the original problem. Yeah, first we have to convert cyclic numbers to fractions. How can we do that? I saw only one answer, but looks it's not correct. Yeah, very smart. For the first answer from Charlie Young, it's true that you see the repeating part has only one digit. So we just write one, the repeating part as the numerator. And the number, you see there are always all nines on the denominator. The number is determined by the length of the repeating part. So let's take the second one as an example. So by this rule, what will the second fraction? Yeah, very smart. Now from Edwin Qian and Jenny Fan, then Nara Feng and Evanston, sorry. Then we can see that it will be 1, 2, 3 as the numerator. And how many nines? Yeah, 999. That's 3 nines, right? Because the repeating part has 3 digits. But it's not the simplest format, right? Always remember to express it as the simplest way, right? You know, it is 41 over 333. Then what about the third one? What about the third one? Yeah, so we have not learned what it is, but at least we know it is 1 plus 0.1 repeated, right? So we know this one is 1 over 9. So overall, it's 1 plus 1 over 9. It can be expressed as 10 over 9, right? So what about 0.01 repeated? Still a little trap here. Most of you said this equal to, let me change another color. This will be equal to 1 over 99. Do you have a calculator by your hand? Yeah, only Janet Young added a question mark. Yeah, I saw the first answer from Edwin Ma, then followed by Hank Sun and Johnson Wang. Well, it's not 1 over 99. Why? When you write 1 over 99, you know it could be also expressed as 0.1 over 99, right? So it is 0.1 repeating, right? You know 0.1 repeated is not equal to, you know the repeating part is not equal, right? It could be written as 0.1, 0.1, 0.1. And the right side is 0 or 1s, right? The right side is larger, you see, larger. So they are not equal, right? Yeah, now the correct answer is 1 over 90. Why 1 over 90? You see, let me change back to the blue one to show it's the correct one, right? 0.01 repeated. It is, let me see, 1/10 of 0.1 repeated, right? Well, let's look back. Moving the decimal to the right side once, right? Moving the decimal to the right side, it will be equivalent to multiplying by 10, right? So it's the same. When we move the decimal to the left part once, it will be equivalent to times 1/10, right? So you know this is 1 over 9. We have learned this is 1 over 9. So the number is 1 over 90, right? Okay, let's look back to the problem now. Question here. This is, you see, 1 over 90, right? Sorry, actually, I think we still have even a better way to do so. That's what? You see, we can move all the non-repeating parts together. Then you see 0.1, 0.2, plus 3, 0.7, 0.8, right? Then the repeating part will be, right? They will be written together. Then right? You see, for the first part, we can still use changing the order, right? We have another pair. All of them had a sum of 1. So overall, the non-repeated part will be 2.1, right? So let's see what's this. This will be, we have a common factor, right? That is 1/10 of what? You see, then we can move all the zeros after the decimal. Oh, sorry, after the decimal, not before the decimal, right? So we have this one. We cannot add them directly, right? As they are repeating. Otherwise, you don't know the rule, right? Now, it could be written as this way. Will it be much simpler? So what's that? Give me, what's that? 1 over what? Yeah, 1 over 9. The repeating part is 1, then it has only 1 digit here, right? So now it's simple, right? Now we write 3 over 9 here. We do not need to cancel 3 on both sides because later when we are doing the addition, we still need to sum it back, right? Here, question here. What could be 0.9 repeated be expressed? Oh, what is the last one? I leave it for you. What's that? Yeah, what's this? You're very smart. According to the rule, I have to write 9 over 9, right? You see the repeating part is 9 with only 1 digit. So it's 9 over 9. Oh, isn't it just 1? Oh, sorry, it could be written as here. This is 1. So let's look back to the remaining part, right? You see, we have 1 plus 8. This is a 1, right? You see 2, 3, 4. They have a sum of 9. So we have another 1. So overall, what is the sum inside the parentheses? You see 1, 2, 3, right? You see the parentheses has the sum of 3. Don't forget to multiply 1/10. So overall, it is 2.1 plus 0.3, right? Well, it's 2.4. Okay. Finally, we have achieved the correct answer, right? Still with a long journey because we are not familiar how to translate the repeating decimals to fractions, right? Now we are quite familiar with that. And we have found something interesting, right? I have pointed that, is it an illusion for you? Is 0.9 repeating equal to 1? Okay, if you cannot realize, you may think that the left part is smaller. You may think that this is smaller than 1. Because no matter how many 9s do we have, the integer part is still 0, right? So it must be smaller than 1. Then let's consider this. Is this one equal to 0.3 repeated by 3, right? And then what's this? This could be expressed as 1 over 3, right? You see 1 over 3 by 3, isn't it just 1? Well, later you will have further knowledges about mathematics. At that time, you will have the rigorous conception of mathematics. Then actually, the essential is that there will not be any real numbers strictly between 0.9 repeated and 1. You cannot insert any real number in the interval because the interval itself does not exist. Okay, well, this will be a further topic for you. For current period, you just remember this way for how to get the equation 0.9 repeated equal to 1. Okay. Now, let's look at an interesting way with fractions on the denominator, fractions on the denominator recursively, right? So, anyone have the correct answer now? I think this will be a little bit faster than the previous one, right? Yeah, I saw Jocelyn has explained why 0.9 repeated equal to 1 to me. Yeah, this also worked, right? Okay, for this problem, I will just give you some time to think. And another hint will be that, let's look at this. One, the reciprocal equal to something, then the number itself equal to the reciprocal of something, right? Well, these two are equivalent, right? Flip. Well, when we have equation, we can do any operations on both sides. Then this time we do not add, subtract, multiply, or divide by anything, but we just do the flip on both sides, right? We do the flip on both sides. Oh, the equation still hold, right? Remember that. Have we found anything? Oh, I saw relevant answer, but according to my memory, looks it's not correct. So to solve this problem, it's just like to peel an onion. What is the onion's level? You know, 1 level, 2 levels, 3 levels. We have level by level, right? You see onion level, onion level. And let's look at a more clear picture, right? Is this the onion? You see onion level 1, level 2, level 3, right? So what's that? I saw an integer answer, but I remember the result is not an integer. So let's forget what this is. Oh, remember it's 8/11, right? Let's look at here. This will be 8/11. So let's see, what is onion level 1? You know the orange one, but maybe the color is not that vivid, right? Question here, what is the value of onion level 1? That is the denominator of the original expression. Onion level 1, what is the value of onion level 1? Give me just a fraction, right? Yeah, it should be flipping 8/11. So onion level 1 equal to 11/8, right? You see, this is 11/8. Then you see 1 plus something is 11/8. So this part, it will be -1, right? So it's 3/8. So let's see that the reciprocal of onion level 2 is 3/8. So what is onion level 2? Let's see, what is onion level 2? Yeah, I saw the first correct answer from Cherry Xu and Hank Sun, and then Sun Yushan. I may miss some correct answers. Let me check. Yeah, Mandy Yu. Oh, once again, looks Mandy Yu has always get the first correct answer, right? Yeah, as every said, onion level 2 is just flipping 3/8. It will be, it will be 8/3 for onion level 2, right? You see 2 plus something will be equal to 8/3. So the reciprocal of onion level 3 will be, you know, we just remove 2 from 8/3, right? It will be 2/3. That is the reciprocal of onion level 3, which will be extremely close to our final answer, right? So you see the reciprocal of onion level 3 is 2 over 3. So itself is 3 over 2. Now let's look at the equation. X plus 1 over 4, it will be 3 over 2. So what is X? What is X? Yeah, finally, every Charlie, Jerry fine. Okay. Now they Jocelyn Wang, they all get the correct answer. So we just move subtract 1/4 on the both sides. So it will be 5 over 4. Right? Okay, you see, that's the way we peel the onion, right? Okay, very good. And finally, Hannah Liu, Evanston, will get the right answer. Okay, this is for problem 4. Well, the next will be problem 5. We're close to halfway. Now, this is a typical AMC 8 style problem. It defines a new operator, star. You know, A star B means A plus A, the next number, until A plus B. It means A, for example, let's take an example for A star 2. The first number will be 1, right? The last number will be 1 plus 2, it is 3. Then the midterms will be 2. So 1 star 2 will be 6, right? Well, this is the definition of star. Well, the operator will be defined by the problem, right? So we just follow the rule. What reminds you of this? What reminds you of this? Let's write what is n star 7. The first number will be m, right? The next is m plus 1. Then followed by m plus 2. Then according to this pattern, the last one will be m plus 7. Question here, how many terms do we have on the right side? How many terms do we have on the right side? Yeah, I saw the keyword from Charlie said factorial. No, it's about addition. 7 minus m, how many terms? Yeah, if it is from 1 to, if it's from m to 7, then you can say that it's something like 7 minus m. So it's still not 7 minus m, right? How many terms there? How many terms here? Okay. I think this problem will be difficult enough for you for current period, right? How many terms do we have? Yeah, very smart. I saw answers from Edward Wang, Helen Liu, Avery Ma, and then Jonathan Wang. Yeah, we have 8 terms. You just ignore m, as all the numbers have m, right? So we just see m plus 0, m plus 1, m plus 2, m plus 7. It will be equivalent. How many terms are there from 0 to 7 inclusively, right? That is 7 plus 1. We have 8 terms, right? So the 8 terms can be written as m to m plus 7. If we regard this as a sequence, what is this sequence called? What is this sequence called? Yeah, smart. I saw the first correct answer from Hank Sun, then Adrian Chen, Avery Ma, Kaden Wu. Good. Now you have found what it is, right? We have some ways. We will do it as a very straightforward way. Let's see, as there is a common, it's not factor, but we have a common number m on all the terms, right? So how many m's do we have? That's why I asked you, as m appears in each of the term. So the number of m will be 8. We have 8 m's in 8 terms, right? Then plus the following part, 0, 1, 2 to 7. And what is this sum? This is called an arithmetic sequence, right? Actually, it is just counting the non-negative numbers from 0 to 7, right? The common difference is 1. You see each number compared by the previous one, it is 1 larger than the previous, right? So as the common difference is the same, it is called an arithmetic sequence, right? As there are not so many numbers, we just see the result. What's that? You see, we have 0 plus 7 is 7. How many pairs do we have? You see, we have 8 numbers, and the first, the last has a 1 pair, right? The second and the second last have another pair. So overall, we have 4 pairs. You see 8 numbers and 4 pairs, right? So each pair has a sum of 7. So overall, we have 7 by 4, which is 28. Now we have the equation plus 28 equals 44. Then you know that it's much simpler than the previous steps, right? Which is 8m equal to 16. Then we divide 8 on both sides to have m is 2, right? Then of course, this is a quite straightforward way. We still have some other choices to solve the problem. That is called to calculate the sum of arithmetic sequence. So as I mentioned, there is a common difference b. In this case, the common difference is 1. Compared to the previous term, each term will be 1 larger, right? So the common difference is the same. It is not necessarily positive. It could also be -1, right? Or -1/2. It does not need to be an integer. It does not need to be positive. Then, as I said, for such an arithmetic sequence, the sum of first n terms, for example, the term is 1, 2, 3, 4 to n. Then what's that? You see, with this equation. So how to get this equation? You know, we write first term to be a1, a2, a3 to an. You know, we don't know how to sum them up yet, right? So we write that again with a reverted order. You see, this time it is an first, then an minus 1, an minus 2 to a3, a2, a1. You see what if we sum them together? It means, you see, we sum the same value twice, right? So it will be double to the sum of first n terms. Then what's that? You see on the left side, it will be double of this value. On the right side, you see we have each pairs have the same sum, right? It will be a1 plus an, the first term and the last term. So overall, how many pairs do we have? Why I write 1, 2, 3, 4 to n? You see we have a 1-1 relationship, right? 1 pair, 2 pairs to n pairs. So overall, we have n pairs, right? That's how the equation comes from. Then we just move 2 to the right side. Now that's where the equation of sum of first n terms of arithmetic sequence come from, right? You don't need to recite the calculation. You just need to remember where it comes from, right? If we express that by language, it is called the first term plus the last term by the number of terms, then half of that, right? Okay. So if we solve this problem again, so this time if we solve this problem again, you see the first term is n plus 1. the last term is n plus, sorry, the first term is n. The last term is n plus 7, right? Then how many terms do we have? We have 8 terms. Then divided by 2, right? It is 44. Right? So we know the solution will be the same. M is still 2, right? Okay, both way work. So just choose your favorite way. Okay. Or let's see, as we are halfway, let's look at problem 6. You know, this time we define a new calculator star, right? This time A star B is defined as B minus A over the product of AB. Then we are going to find 1 star 2 minus 2 star 3, 3 star 4 till 2020 star 2021. So what's that? We have such a long calculation. So what could it be? What does it remind you of? Right. Well, here is some hint. It's called telescoping, right? Well, the methodology we are going to introduce is called telescoping. You see, we will have a long telescoping to look far away, right? But the telescoping is not easy to carry with this format. So what will we do is to fold it. When we fold it, we push, you see, we push on both sides. That will be a very quite short one, right? So here, we know we are going to use telescoping, but how? It means the keyword canceling all the midterms, right? Let's look back to the original problem. Where are the middle terms? Can you find the middle terms? Where are the middle terms? Where are the middle terms? Let's look back. Let's express it this way, okay? You see A star B. It will be B. Let's write it this way. You will see this will be a very typical AMC 8 style problem. So what's that? Can we simplify this? Yeah, very smart. I saw very good answers in Xiaoge system. Yeah, I can see the first answer coming from Rian. Yeah, why you're just typing the dots. Problem 6. So can we simplify this? It will be 1 over A minus 1 over B, right? By canceling the common factors on both sides. So it is just 1 over A minus 1 over B. We express that with, you see, a more complicated way, right? So let's see. Let's see, 1 star 2 will be equal to 1 over 1 is just 1, right? It will be 1 minus 1 over 2, right? Then let's look at, as they are all subtracted from the sum. So it means the inside will be the sum, right? 3 by 4, star 4, sorry. When I see star, I always say that's multiplication, but it's not here, right? 4 by 4 stars 5, then to 2020 star 2021. Okay, here it's just 1/2, right? Then what's here? It will be 1/2 minus 1/3 plus 1/3 minus 1/4. Gradually, when we write some terms, we finally find how to telescope, right? That is telescoping plus minus plus minus. Question here, what is the last term? You see, we can write one more term, right? It will be 1 over 2019 minus 1 over 2020. Then the last term will be plus 1 over 2020 minus 2021. Yeah, next we will show you the time of magic time. Let's see the magic power of telescoping. Cancelled, cancelled, cancelled until here. Right. So what's that? What is the final answer? You look, we still have a parenthesis, right? We have to open that. You see, when it is opened, it will be 1/2 minus 1/2. Remember here, it is minus here, right? So after removing the parenthesis, it will be reverted to plus, right? 2021, right? So it will be canceled again, and there's only one term left, right? Okay, the number is simple. It is 1 over 2021. Well, let's make some update on the problem. For example, if we continue to minus until we minus 949 stars 10,000. So without calculation, can you tell me directly what the number is? Can you tell me directly what the result is? Yeah, very smart. I saw Evanston, Helen Liu, Charlie Yang, and anyone in shower system? Yeah, Reed. Yeah, you all get the correct answer. You know the essential of the telescoping, right? All the midterms are canceled after expansion, right? Then actually, you know, these two terms will also be canceled. They're the last term remaining, right? Well, the last term will actually be the reciprocal of the largest integer appearing in the equation, right? So here, when it is 2021, we know it's 1 over 2021. Then if it is 10,000, it will be 1 over 10,000, right? Okay, so look, you have remembered also by Ian. Okay, correct. Now you understand what it is. Now, telescoping. Okay. Now, as you did a quite good job, let's move on to problem 7. I think problem 7 will be a snack for you, right? Well, everybody be careful about the number. Look carefully. What it could never be larger than 1, right? You see the first term is 1 over 2. It's always minusing the positive terms, right? So it could never be larger than that. Oh, smart! I see correct answers coming out from Claire Zhou, Jocelyn Wang, then Lily Yi. Oh, you like drinking the tea? Good. Ethan, I saw Ethan Cao. Your answer is close, but not correct yet. Okay, as I introduced that here we do have an arithmetic sequence, right? Okay, let me change to blue. We do have 2 arithmetic sequence, right? If you like, you can do it this way. First term plus last term. Question here. How many terms do we have? Question here. Now I can see Grace, 乐之、慧玲、日出之息. As rising sun, right? 一婷. Yeah, you are all correct. And then 等等奔奔 What a cute name. Let me see. In Zoom, we have Sun Yushan, Nara Feng, then Kaden Wu, Hank Sun, Adrian Chen, Julia, your answer is wrong. Amber Wu, Avery Ma, Helen Liu. Okay, Melody Song. Okay, you are all getting the correct answer. Very smart. So which means as you can get the answer very quickly, it means you didn't use this way. Oh, let's see how to find the correct answer by this way. So what you remember, first term plus the last term by the number of terms. How many terms do we have? Yeah, we do have 1011 terms here. Why? Because we can express the term as 2 by 1, 2 by 2, 2 by 3 until the product of 2 by 1011, right? So you see as 2 is the common factor appearing in all the terms. That means if they have the same pattern, right? Then we just look at here, 1, 2, 3. It's countable, just counting from 1 to 1011. There are exactly 1011 terms, right? Then divided by 2. And here it's the same, right? It will be 1 plus 2021 by, right? Now, if we move the common factor 2 over 1011 out, then the remaining part will be, you see, 2024 minus 2022. That will be 2. And the numerator and the denominator will be canceled, right? So the final answer is 1011. But I believe for those who just typed the correct answer 5 seconds within the time I show you the problem 7, you must have the other solution, right? Okay, I think you have already find the other solution. It will be much simpler. I believe most of you have already find that. Now we make pairs, right? 2, 1, 4, 3, 6, 5. You see the last 3 terms, 2022, 21, 20, 19, 8, 7, 18, 17, right? And no matter what the specific value are, the left side is always, the term in first sequence is always 1 larger than the term in second, right? Oh, sorry, it should be 4 minus 3. Then the next 6 minus 5. And the last several terms will be 2018 minus 2017. Then 20 minus 19, then 22 minus 21. Yeah, very simple, right? All terms of 1. So question again, how many terms? The key point is how many terms. We have already known that it's the same to the previous solution, right? 2 by 1, 2 by 2, until 2 by 1011. So overall, we have 1011 ones. It's much simpler, right? Just forget what the sum of arithmetic is. And just forget that. We have all 1011 terms of 1. Okay, congratulations. We did a very good job in problem 7. As I said, it will be a snack for you, right? The key point is that you need to find the simple format, right? You need to find that the corresponding pair, each one in the left sequence is 1 larger than the corresponding one on the right. Well, then we have all ones here. The second key point is that we should know how many terms do we have, right? And I have a suggestion that next time if you don't know how many terms there, always write the numbers as the same format. Here we use 2 by 1, 2 by 2, 2 by 3, then to 2 by 1011. We made it countable, right? It's much simple. It will be very simple. For example, next time we can write as 2 plus 5, 2 by 2 plus 5, and to something. So always try to make the equations countable, right? The sequences, let them to be countable. Okay, it will help you to find out how many terms are there. Okay. Now, problem 8. Problem 8. Let's see, it will be 1 minus reciprocal of 2 squared by 1 minus reciprocal of 3 squared to 1 minus reciprocal of 99 squared. What's the value? Well, we will try to solve this problem by 2 ways. Yeah, pair up. Yeah, I saw in Xiaoge system, Rin said in pairs. Very correct. Okay, then now let's find the first several terms to find the pattern. For this kind of problem, at a first glance, you may not have a concept how to simplify the calculation and how to find the methodology. Later, you will see the keyword again. But before that, I will tell you a more, let me see, common way that is called to find the pattern. Yeah, we just write the first several terms by the definition, right? You know, each term will be based on the previous one. You see, the first one is 3 over 4. Then it will be multiplying 1 minus 1 over 9. That is 2 over 3, right? Can you find the pattern? Here, as I have given you the first 6 terms, can you find the pattern? Can you find the pattern? Yeah, we have written some of the terms, but unfortunately, the patterns are not that clear, right? You see the numerator decreasing, then increasing, decrease, then increase, decrease, then increase. Oh, it has no relations, right? But if we make some change, if we make all the denominators even, you see 2 over 3 is exactly the same as 4 over 6, right? Well, this time, will it be clear for you what is the pattern? What is the pattern? Well, now you can see what will be the next term. Well, following this pattern, what will the next term be? We don't need to calculate the answer up to now. Right, it's very smart. Each time you increase the numerator by 1, sorry, increase by 1, not 1. Then increase the denominator by 2, right? Then what is, sorry, we are calculating A99, right? Let me see how many terms are there. I forget the original number. Yes, from 2 to 99. Question here, from 2 to 99, how many terms are there? You see, this is not 99 because we're counting from 2, right? This is, let's look here, it's 2 squared, 3 squared. So 99 squared, what are we going to calculate? Which term? What are we going to calculate? You see, the first term is 2 squared. Second term is 3 squared. So 99 squared represents a what? Represents a what? Yeah, it's not a 99, but a 98. Right? So here, question, the problem is equivalent to what is the value of A98? Remember, it's not neither 99 nor 100. We count from 2 to 99. There are overall 98 numbers, right? So we have already found the pattern. Each time the numerator is increased by 1 and the denominator is increased by 2, right? So how many times is it increased? You see, from 1 to 98. From 1 to 98. How many times did we increase? You see, 2 is once, 3 is twice, 4 is 3 times. So 98 is 97 times, right? We increase the numerator by 97. Then we increase the denominator by 97, also 97 times, but each time increased by 2, right? What's that? Well, it's simple, right? The numerator is 100, while the denominator is 98, right? So what's that? It could be simplified to, is it? Yeah, but do we have some other solution to do so? Oh, let me look back. Do we have any other way to do so? You know, in AMC 8 level, we need to know some basic algebraic calculations or equations, right? So tell me, what is this? You see, the previous solution, it's commonly used because you can always find the pattern. But sometimes the pattern is not easy to find. You see, I give you a hint that to make the denominators even, right? Then later you know that each time the numerator increased by 1, the denominator increased by 2. But the pattern is not that easy to find. So we will find another way to do so. Do you know that a squared minus b squared can be expressed as a plus b, a minus b, right? That is the algebraic way. Then a hint. Then we still have other equations like this. A plus or minus b squared equals a squared plus b squared. No matter whether here is plus or minus, here is always a squared minus b squared. Then plus, if here is plus, here will also be plus, vice versa, both minus, right? Twice the product of AB. So remember, that will be the basic equations about algebra, right? For algebra, you see 1 can be expressed as 1 square, right? So what is 1 square minus 1/2 square? Look, it's just A. 1 is A and 1/2 is B, right? It could be written as 1 plus 1/2, 1 minus 1/2. Similarly, 1 minus reciprocal of 3 squared, it is 1 plus 1 over 3, 1 minus 1 over 3. By this pattern, 1 minus 1 over 99 squared can be expressed as 1 plus 1 over 99, 1 minus 1 over 99. So what reminds you of this production? We divide the equation into twice as many terms as the original one, right? You see, each term is divided into a plus by the minus 1, right? So previously we have 98 terms, and now we have 196 terms, right? What are we going to do? So guess, what are we going to do? Let's look at here. If we multiply the sums together and the subtractions together, let's see what happens. Question here, what is 1 plus 1 over 2? 1 plus 1/2 is, 3 over 2, right? Then you see this is multiplied 4 over 3, then 5 over 4. Let's write more terms, 6 over 5. Then 100 over 99. What's that? We have learned one keyword. Well, type the keyword into the chat room together. Can we? Yeah, very smart. Let's type the keyword together and say it. Telescoping. Yeah, very smart. Telescoping. Remember, telescoping, it does not apply only to addition and subtraction, but also to multiplication and division, right? Telescoping, always remember the keyword telescoping. So there are only 2 terms left. The last term, 100 on the numerator and the 2 on the original, the first term on the denominator. So that is 100 over 2, it's 50. So you know what I'm going to do. It's half, the additional half is handled. It's 50, right? But don't forget, we still have another half left, right? So you know 1 minus 1/2 is 1/2. Then 2/3, 3/4. Then, of course, sorry, not this one. It should be 6, 5. Oh, no. 4 over 5. Then 6, 5 over 6. Until the last term, 98 over 99. So what's that, right? You see, once again, let's say the keyword again. What's that? A keyword again. What's that? Yeah, telescoping again. So canceled. All midterms are canceled. And there are still 2 terms left. 99 as the denominator and 1 as the numerator. So the other part, the first half is 50. The second half is 1 over 99. So don't forget to multiply them together again. So the final answer will be the same as the first solution, as they are representing the same equation. So they must have the same value. 99, not 90 here. Well, for the first solution, we found the pattern of the equation. Actually, not the equation, but the sequence, right? Each time the numerator increased by 1 and denominator increased by 2. So we just find how many times did we increase, right? The second one is that we divide the terms with the equation a squared minus b squared can be expressed as a plus b, a minus b. Then put the plus together to have the first telescoping and put the minus together to get the second telescoping, right? Then 2 telescoping together, we will see the magic time, right? 50 over 99, right? That is, you have already seen the power of telescoping many times, right? So always keep that in mind. I suppose for the whole week, your keyword in your mind will be telescoping. Okay. A good job in problem 8. Then let's have problem 9. Well, given A, B, C are integers, well, not necessarily positive, right? Well, find all the possible numbers of integers in each mean of pair of the 3 numbers, right? The mean of AB, AC, and BC. We have originally 3 integers, then we have 3 means, right? We are going to find the possible value of integers inside. Now, for example, when A, B, C are all even. Let's see. For example, they are 2. 2, 4, 6. Then no doubt they will be all integers, right? You see A, B, A plus B, A plus C, B plus C will be all even. So the number are all integers. So 3 could be the first possible answer, right? When we see the keyword, all the possible answers, it means it could be a multiple answer here, right? Now, do you know what the problem is asking about? Then could there be no integer here? We can see all integers, right? And could there be no integer? Could there be no integer? I think this problem will be much easier than problem 8. It's just testing something. I'll give you some hint. When A plus B is even, then the number of the mean of A plus B will be integer, right? They are equivalent. Then similarly, when A plus C is even, then the mean of A and C will be an integer, right? This is a hint. So what is the possible numbers of integers of these 3? You see, I have shown you a sample of 3, right? Any other answers? Now, I am asking about, we have 3 integers. You see here, we have 3 integers, so the answer is 3. I'm not asking you about the specific value of A, B, C, but how many of these 3 could be integers? Of course, all 3 could be integers, right? Could there be no integer inside these 3 numbers? The question is about this, not a specific value of A, B, C, right? I know there are infinite many possible values for A, B, and C, but they are limited value of these 3. You see, actually, I can change a way to ask. As there are 3 numbers, the possible values could only be from these 4, right? 3 is correct. I've given you a sample that A, B, C be 2, 4, 6 accordingly, right? Then could there be any other answers? Yeah, very smart. I have some correct answers from Edward Huang, Avery Ma, and Adrian Chen, then Julia Wang in Zoom, and Tie Guanying, Rin in Shower System, and Lily Yi. Sorry, I nearly forgot you. Yeah, very smart. There could be 2 answers. One is also a possible value. But for example, if we change A to 1, you see A plus B is even. A plus B is odd. So this is not an integer, right? Well, it's the same. A plus C over 2. It's also not an integer. But once again, B plus C, this one is an integer. So we have 1 here. And question, could we have no integer or 2 integers? Exactly 2 integers. Could it be true? Could it be true that we have 2 pairs of integers? When we have 2 pairs of integers, let's look at, let me clean the whiteboard. Let's see. Let's see first for A plus B, A plus C, and B plus C. If we sum these three pairs together, what do we get? What is the sum of these three? So we will have each number appearing twice, right? So here we have, we have either three pairs of integers or only one pair, right? You will see why. Because the sum here is even. It will always be even, right? You see three numbers have an even sum. So what could they be? Why it is even? Because it is it is a divisor, sorry, not a divisor. It is a multiple of 2, right? You see, no matter what A, B, C are, it is always a multiple of 2. So it is even. You see, three numbers have a sum of even. So they could either be all even or two pairs of odd plus even. No other possibilities, right? Only these two groups, right? You see one, they are all even. Then we have three integers. I said that the mean is an integer will be equivalent to the number itself. The sum is even, right? It is equivalent. Here we have three pairs, right? Here we have only one pair, so they are equivalent. Okay. That's for problem 9. Well, when you notice that the sum is even, you will get half of the conclusion, right? You just separate the cases into 2. All even with 2 odd and 1 even. Only these two cases, right? They have the number of 3 and 1. Okay. Let's look at problem 10. Well, in 1 year, AMC 8 has the last problem similar to this. You see, we have 1015 multiply 2021 threes. Well, of course, we cannot write down the product, right? But at least we can calculate the sum of all digits, right? Well, given such a problem, we are a little bit behind the schedule. We will continue this problem. Sorry for the extension. Well, you will have more time on that. Okay, but let's try to solve the problem together. You see, this problem will be at the last problem difficulty level in AMC 8. So if you successfully challenge this problem, probably you will have a top 5% or even top 1% in AMC 8, right? Yeah, it's not that easy. 1010 plus 2021. Let's look at something first. Well, so for multiplication, we always like to multiply by 10 by 100. But we are not always that lucky. But sometimes it also works for 9. You see 15 by 9. It's just 15 by 10 minus 1, right? With the distributive rule of multiplication, you can use 150 to minus 100 or to minus 15. Well, that will be by 99, the 100 minus 1, right? Well, typically, it's hard to calculate such a multiplication, right? But with so many 9s, we always have the chance to simplify the calculation by distributive rule, right? So let's look back to the problem. Yeah, I saw first answer from Hexun, which should be close. Well, up to now, I don't know the correct answer, but I can say that I can see Hank's answer at least relevant to the final answer, right? Congratulations. Let's see. But unfortunately, we don't have all nine here. We don't have all nine here. What can we do? Question here. Yeah, let's look at the multiplications. You know, one of the divisor will be fully composed by all nines, right? So we don't have such a number here. What can we do? Question, what can we do? Yeah, so we don't have all nine, but we can make one ourselves, right? If the number is multiplied by 3, no, 2021, nice, right? If we multiply the number by 3, isn't it a number fully composed by 9? But it's not allowed, right? We cannot multiply the number by 3 without any reason. But what if we multiply a 3 here, then divide it by 3 here? So what will be on the left side? Yeah, after multiplying by 3, we should do the divided by 3 operation as well, right? So remember, yeah, 15 is divisible by 3. So we could be writing 0.5. Remember, we are using the leading 0, right? Because it will make us noticing how many digits are there, right? So we have 10,000 this time, we have 1,010 0.5, not 15s again, right? So according to the distributive rule, we will multiplying questions. How many zeros here, right? And you see, by adding by 1, there will be a multiple of 10, right? We have so many zeros. How many consecutive zeros do we have? I give you an example. 9 plus 1 has 1 0. 99 plus 1 has 2 zeros. So given 2021 nines, how many zeros do we have? How many zeros do we have? Yeah, as Avery said, there is still a small trap. Yeah, 2021. You see how many nines? The number of 0 will be the same as the number of 9. Yeah, after adding by 1, we do have one more digit. But you know, 1 9 here, 1 0 here, 2 9 here, 2 0 here. Then 2021 9 here. We have 2021 zeros here, right? Minus 1. Okay, then things become interesting. Yeah, I saw Yiren answered its year of 2021 here. So the answer is 2021. Well, it works. No matter how you get the conclusion, at least it works, right? Now you see we will be calculating 0, 5, 0, 5, 0, 5, followed by, you see, 2021 zeros, right? Remember, when multiplying 1 followed by all zeros, the number of zeros will not be changed, right? So while I retain the leading 0, you will see a number like this. Then minus what? 0, 5, 0, 5, 0, 5. How many 0, 5s are we subtracting? 10, 10 or 1010, right? Okay, now you know why I am writing 0, 5 instead of 5, right? Because it will help us know that where should we subtract from. You see, how many digits do we have here? How many digits do we have here, including the leading zero? How many digits do we have in the second term? How many digits this time? Yeah, 2020, including the leading one. Then we have 2021 number zeros here. So we subtract from here, right? So the number you see, we do not change any of the previous until here. You see, we have 2000, we have 10, we have 1010 pairs, right? So now for the previous, how many pairs of 0, 5 are not changed? You see only one pair is changed to 0, 4. So we have 1009 pairs of 5, right? You see, overall, we have 1010 pairs of 0, 5, but the last pair is changed to 0, 4 to subtract, right? Then what will be this? What will be the following digit? What will be the next digit to 4? What will be the next digit to 4? We are doing the subtracting, right? It's 9. Then here we need to minus 0, 5, 0, 5, 0, 5, right? We are removing 0, 5, 0, 5, 0, 5 from here. So what's that? Remember, it will be 9, 4, 9, 4, 9, 4 until the last 95. So how many 9 4s do we have? Question, how many 9 4s do we have? You see, overall, we have 1010 pairs of 0, 5, right? You see, we have 2020 digits here. So we still have 1009 pairs of 9, 4, right? Followed by the last pair, 9, 5. Okay, now we have found that. Let's write the final result again. It could be expressed as 0, 5, 0, 5, 0, 5. How many pairs? 1009. Followed by 0, 49. Well, this is a constant value. And then followed by 94, 94, 94. How many pairs? Still 1000. Oh, what happened? Oh my God. It does not work. Sorry. As it does not work, it stopped at last. So we just calculate. I will see that as we still can see the result, right? It's 5. You know, each pair of 0, 5 has a sum of 5. So 1009 times 5 plus, you see, oh, though it's 49, but you know, 49 and 94 both have the sum of 13, right? So we have one group of 49 and 1009 groups of 94. So overall, we have 1010 groups of 13 as sum of digits, right? So 13 by 1010 plus 5 by 1009 plus the last 95 has a sum of 14. So of course, you can calculate that on your paper, right? You know, up to now, I don't know the answer, right? But we can calculate it. Well, it's unfortunate that we, oh my God. It's unfortunate that finally the machine went naughty, but it's okay that we have all the problems down. At least you can look back to the last number. It is written on the blackboard with each digit, right? We can calculate sum. Then let me say something about our homework. Your homework contains 20 problems every week. So the 20 problems are divided into 4 sections, each section with 5 problems, right? And of course, the first will be the easiest, while the last will be the hardest. So each time you have 20 problems, and the problems has only 2 types. One will be multiple choice. We give you 5 choices, which will be the same as AMC 8 real test. The other kind will be numeric answers. You just need to fill in. They are actually not only numeric, but also integers. You can fill in a non-negative. Remember, non-negative integers. When the answer itself is negative, we will sometimes put an absolute value to make it non-negative. So always remember, the answer has only 2 types. One will be multiple choice. One will be integer, right? So for integers, you don't need to write plus, minus, because they are always positive, non-negative, right? So remember that. Okay, so I think, thank you for your time. And this is the first week of us. Then you will have, your homework will be published soon after the class. Then we have several TA sessions. Well, considering the time zone, there will be both for US students and Asia students, right? The schedule will be, the schedule of US TA sessions has been announced, while that of Asia time will be later posted to you. And if you have problems about your homework or live session, you can contact us, either the TA or directly to me. Okay, that will be, we are all set for the first week. Thank you. See you next week. We will enjoy our 7 months journey together. So see you next week. Bye.